In this video we're going to talk about the uniform distribution. That would be the discrete uniform distribution. There's a continuous version of this that we'll learn about next week. But basically the uniform distribution says that all of the values that we can take on, that the random variable can take on, and there's a finite number of them, and they're integers, and they all have the same probability. So we'd say any values including a and b, but between a and b, are equally likely. And so this is what the distribution characteristics are. We have two parameters. The lower one is a and the upper one is b. So a is the lowest value that the random variable can take on, and b is the maximum value or the highest value. And the probability density function, instead of actually writing it out in a table, we can write it out as a function. So we say the probability that x is equal to any particular value of x is going to be 1 divided by b minus a plus 1. And we'll look at an example of this to hopefully will make it more clear in just a minute. But that's the probability density function. The probability of the cumulative distribution function, CDF, can be written as x minus a plus 1 divided by b minus a plus 1. And this is just the probability that the random variable is less than or equal to any particular value of x. The domain tells us the values that x can take on. We've already specified that, but we'll look at it again. It starts at a, it's the lowest, a plus 1, a plus 2, and so forth all the way up to b. So this is just integer values. And the average, or the mean, is just the average of the endpoints, a plus b divided by 2. That's because the endpoints, or because every single observation has the same probability, so all we have to do is average the endpoints. Standard deviation is given by this formula. It's the square root of the quantity b minus a plus 1 squared minus 1 divided by 12. And in Excel we can randomly generate these things if we use rand between a comma b. We're not going to use that function, but I will point out that there are lots of functions that are already built into Excel that allow us to deal with some of these random variables. So the classic example of a uniform distribution other than flipping a coin is rolling a die. So we've got a 6-sided die, and any value between 1 and 6 is equally likely. We could say, what's the probability of getting any of these when we roll the die? And here's the PDF. It's just 1/6. That's the height of this function here for all values 1 through 6. So this height is going to be equal to 1 divided by b minus a plus 1, so that's 6 minus 1 plus 1, or 1 over 6. That's the height here. To find the CDF, we would use the formula x minus a, so x minus a plus 1 divided by b minus a plus 1. And so if I take a value of x and I plug it in to this formula, it's going to tell me the height of this function. And this is, again, the probability x is less than or equal to some little value of x. So if I'm talking about probability that x is less than 3, less than or equal to 3, I plug it in here and I see that that's 50%. And to find that, I would come over and say, well, here's probability x is equal to 1, probability x is equal to 2, probability x is equal to 3. If I add these three values up, then I get the height of this function over here. And I can show that this is the probability I'm looking for. Probability x is less than or equal to 3. It's going to be 3 minus 1 plus 1 divided by 6 minus 1 plus 1, which is 3/6, or a half. And we can see the PDF written out here again as 1 over b minus a plus 1, so 1 over 6. We can calculate the mean That's just going to be the average of the endpoints, so 1 plus 6 divided by 2. Turns out to be 3.5. You might say, am I ever going to see a 3.5 when I roll my die? And the answer is, of course, no. You're never going to see 3.5. But if you rolled the die over and over and over and over again and kept track of what the values were that you rolled and then added them all up and divided by the total number of rolls, you would see that it converged to 3.5. Can calculate the standard deviation using this formula: square root of b minus a plus 1, quantity squared minus 1 divided by 12. So plug these numbers in and we get a standard deviation of 1.7. So we've got some very interesting ideas here. We can write down the probability, the PDF, probability that x is equal to some number, and we can also write down the CDF that you saw in the slides before, and we can plug numbers of x in for the CDF and get a probability back. You can't always do that, but in this case you can, and it's very straightforward how to do that in this example. And now we're going to turn our attention to the Bernoulli and binomial random variables in the next video. So we'll see you there. Send me an email if you have questions.